Hello class, welcome to Geometry Lesson 9.1, which is all about polygons and the coordinate plane. By the end of this lesson, you should be able to use the coordinate plane to analyze geometric figures. So this is going to combine a bunch of previous knowledge in this chapter, okay? So if we look at this first example, we want to say connect algebra and geometry through coordinates. So what formulas can we use to identify properties of figures on the coordinate plane? So letter A, which formula can you use to find AB? So if we're thinking about AB, A is right here, B is right here. And if I want to find the distance between them, I'm going to use the distance formula. So for those of you that don't really remember how to do the distance formula, quick refresher, it's when you take your x values and find the difference between them. You square it, and then you find the difference between your y values, and you square it, and you add those two numbers together. So in this case, I would be taking the square root of, let's see, an x value, I have a 3, so I could say 3 minus my other x value is 1 squared. And if you wanted to do 1 minus 3, that's okay. And then since I started with the 3, I need to start with the y value from that same point. So I'm going to say 1 minus 6. And if you, for the first parenthesis, said 1 minus 3, your second parenthesis would say 6 minus 1. Okay? So 3 minus 1 is 2. 2 squared is 4. 1 minus 6 is negative 5. Negative 5 squared is 25. That means the distance between them is the square root of 29. Okay? Letter B, what point bisects segment AB? Remember, bisect means cut in half or halfway. So what's halfway between A and B? That means we're going to use our midpoint formula. So in order to find our midpoint, I'm going to add my x's together. So I have a 3 and a 1. Divide by 2. My y's 1 and 6. So I'm going to say 1 plus 6. Divide by 2. So 3 plus 1 gives me 4. 4 divided by 2 is 2. 1 plus 6 is 7. 7 divided by 2 I'm just going to leave as a fraction. And that is the point that bisects AB. Okay, so distance formula, midpoint formula. Letter C, why do slopes of segment AB and segment BC show that the measure of angle ABC equals 90 degrees? So slope, remember, it's been a while. Slope is y2 minus y1 over x2 minus x1. And if they are 90 degrees, that means our slopes are opposite reciprocals. If you remember, so if I have a 1/2, my perpendicular slope is negative 2 over 1. So that's the situation we're looking for. Let's find the slope of segment AB. So I'm going to take my y value. So if I start with 6, and then my other y value, I'm going to say minus 1. Since I started up here at the 6 for the y, that means I have to start with the 1 for x. So I'm going to say 1 minus 3. So 6 minus 1 is 5. 1 minus 3 is negative 2. That's the slope for AB. Now the slope for BC, let's see. If I take the y value, I have a 3 minus 1 over 8 minus 3. So 3 minus 1 is 2. 8 minus 3 is 5. So are these opposite reciprocals? So remember, reciprocal means that you take a fraction and you flip it. So in this case, I started with 5 on top and 2 on bottom. And then for the next one, I had 2 on top and 5 on bottom. So they're reciprocals. And opposite just means one's positive, one's negative. In this case, they are. So the reason they show that it's a right angle is because they have opposite reciprocal slopes. So there's all of your previous knowledge. Distance formula, midpoint formula, and slope. Now we're going to use that repeatedly throughout this lesson. But why don't you look at this triangle ABC and find what is the length of the line segment, connecting the midpoints of segment AC and segment BC. So I want the length of the line, so that tells me I'm going to do distance, but I'm going to do distance with the midpoint. So first start by finding the midpoints, then find the distance between the midpoints. Good luck. Hopefully for your answer, you ended up with the square root of 7.25. But if you did not get the square root of 7.25, and you said instead 2.69, that is also a correct answer, okay? Now, let's talk about classifying a triangle on a coordinate plane. So, if I want to figure out if something's equilateral, isosceles, or scalene, that means I'm going to be doing the distance formula on each side of the figure in order to figure out if they have the same measures or different measures. Remember, equilateral triangles have 3 congruent sides, isosceles have 2 congruent sides, and scalene have no congruent sides. Okay, so I've already refreshed your memory on distance formula, so I decided not to write it out again. The book did it for us. X, Y, they figured out, they found that it was the square root of 52, square root of 13, and square root of 65. Since they're all different, the triangle is scalene. And then letter B, if I want to figure out if it's a right triangle, I mean, you could go through and you could find all of the slopes and see if you have any opposite reciprocals. But a faster way, if you already know what the 3 measures are, we have Pythagorean theorem. I can say the square root of 52 squared is, let's quickly refresh our memories on that. Remember, squares and square roots cancel each other, so then you're left with just whatever's under the square root. So in this case, that's 52. So then this ends up becoming 52 plus 13. Does that equal 65? It does, so we know that this is a right triangle. And make sure that when you set up a Pythagorean theorem to try to figure out if it is a right triangle, the side that's the biggest always needs to be on its own. Why don't you go ahead and solve this next one? Good luck. All right, for this problem, hopefully you ended up with 2 sides that were the same length, so you knew that they were, or that this forms an isosceles triangle, and you figured out if you do Pythagorean theorem, it doesn't work because our 2 congruent sides happen to also be the longest sides. So we would say that they are not, they don't form a right triangle. Another quick side note, this is another chapter where we're going to practice simplifying radicals. So the square root of 40, I could split up into the square root of 4 times the square root of 10, which becomes 2 square root of 10. Just like 32, I could split up into the square root of 4 times the square root of, or actually the square root of 16 times the square root of 2, which becomes 4 square root of 2. Okay, so you will have to practice that this chapter. All right, example 3, let's talk about classifying a parallelogram on a coordinate plane. So if I want to figure out what type of parallelogram is RSTU, so remember, parallelograms are kind of the biggest category of quadrilaterals that have 2 opposite sides, or 2 sets of opposite sides that are parallel. Parallelograms, then more specifically, it becomes rectangle and rhombus, and then if it's all of those, it is a square. So we're going to go through the process to see what figure do we have. Okay, so what type of parallelogram is RSTU? So first we have to find the distances, and you don't have to do it on all 4 sides, because if we know it's a parallelogram, we know we have 2 sets of congruent sides. So that means I would only have to do it on let's see, RS, because that's the same as UT, or and I would have to do it on either ST or RU, because those are the same. So if I do that, distance formula, I get square root of 52 and square root of 10. And then since not all side lengths are equal, RSTU is not a rhombus or square. Because remember, rhombi and squares have all four sides are congruent. So if you got the same measure for both sides, immediately you're going to think maybe it's a rhombus or square. So now we know that it's not a rhombus, not a square. So that leaves us with parallelogram or rectangle. So in order to know if it's a rectangle, what I can test is the slopes of the sides to see if I have right angles. So if I find the slope of ST and I compare it to one of the shorter sides, if it's a rectangle, there'll be opposite reciprocal slopes. So if I find the slope of ST, I end up with negative 2/3. If I find the slope of RS, I end up with 3. Those are not opposite reciprocals. Therefore, they do not form 90-degree angles. So I can rule out rectangle, and that means that this is just a parallelogram and not a rectangle, rhombus, or square. Why don't you go ahead and take a look at this problem on your own? Good luck. All right, hopefully for this question you figured out it's not a rhombus because we do not have congruent sides, but it is a rectangle because if we check the slopes, we have opposite reciprocals, so they form right angles. All right, one last thing on that question. I recommend if you're ever just given vertices, maybe try just even a rough sketch of plotting them out so you have a nice visual, so you end up choosing the correct sides. Sometimes I see students that without the visual, they end up trying to compare AB to DC. And then they're like, oh, cool, I have congruent sides. So that means that this is a rectangle, or this is a rhombus or a square. But that they got false information because they chose opposite sides, which are always going to be congruent in a parallelogram. Okay, so example 4. What if we want to check for a trapezoid or a kite? So you're still using the same tests. Remember, a trapezoid has exactly one pair of parallel sides. So we've talked about perpendicular slope. Parallel slope is when they're exactly the same, okay? So that means to check for a trapezoid, you do the slope of all four sides. So they found the slope of AB was negative 2/3, BC was 1/2, CD was 4, and AD was 1/2. So if you notice, we have two sides that are parallel to each other. And since we have one set of parallel sides, that means that this is a trapezoid. That is all you have to do to check for a trapezoid. Okay? And then if we want to know if something's a kite, the way you do that is a kite has two pairs of consecutive congruent sides and no opposite sides. So for a kite, you're going to use the distance formula to find the distance of all four sides. And you can see right away, okay, I have two sets of congruent sides, but the key part of making this a kite is they have to be right next to each other. So again, this is where drawing a rough sketch of where those points are really helps. So KL needs to be congruent to LM. And it is. They're both the square root of 10. And same thing goes for KJ and MJ. Both need to be congruent as well. And since they are, that means that we have a kite. So I think you guys have seen the pattern by now. You're doing a lot of distance formula, slope. You're doing a lot of midpoints. It's a lot of the same thing. And then just knowing what makes something a parallelogram, rectangle, rhombus, square, kite, trapezoid, all of those things. So I want you to check to see is either quadrilateral a kite, trapezoid, or neither. All right, hopefully for this problem, you said that letter A is a kite because you have two sets of consecutive sides that are congruent. And then letter B is actually neither, because if you find the slope, none of the slopes are parallel. And also, if you look at the sides, you can see that we don't really have two sets of congruent sides going on either. So I totally, just from a visual standpoint, skipped the kite test for that one. Okay, example 5. So I'm not going to go through and actually solve this. I just want to talk you through how you would solve it. So if we look at this example, we're talking about finding perimeter and area. So Dylan draws up a plan to fence in a yard for his chickens. The distance between grid lines is 1 foot. So we want to know, is 30 feet of fencing enough to enclose the yard? The way that we would figure that problem out is we would find the distance of all 3 sides, and we would add them together. And we would see if I take the lengths of all 3 sides, add it together, is it less than 30? If it is, I have enough fencing. If it's not less than 30, then I need more fencing, or Dylan needs more fencing, I guess. The more complicated problem in this example is finding the area. So to find the area of a triangle, you guys know is 1/2 base times height. You guys have been working with that for a really long time by now. And the really important thing to know about finding the area on this triangle is first of all, if I had already done letter A, I would know that AB is 10, I would know that BC is 10, and then this other side I would have found is the square root of 80. Okay, so that's what I would have found in letter A. Letter B, now what I would use is I need to find the height of this triangle. Remember, height of a triangle always has to come from a right angle. It has to come from an altitude. So we have to find what that distance is. So that means I have to find the midpoint of AC. So if I found the midpoint of AC, I would say 2 plus 10 is 12 divided by 2, and then I would say 6 plus 2 is 8 divided by 2, so my midpoint is at 6,4. And then what I would do is I would find the distance between my midpoint right here and this vertice right here, and that would give me my height. And if I were to do that, I would find that the height of the triangle is also square root of 80. It does not always work out that it matches the bottom, but in this case it does. So then I would do 1/2 times the base, which is square root of 80, times the height, which is square root of 80, and that gives me my area. So the square root of 80 times square root of 80 just becomes 80, and I'm multiplying that by 1/2, and I get 40 yards squared. Okay, so that is how you would solve that problem. To find the area, first find the altitude, which you do by finding the midpoint of the side and the distance between the midpoint and the opposite vertice, and then you can plug it into the area of a triangle. I'm going to have you skip that, and here's our concept summary. If we look at this concept summary, it helps you figure out all of the different techniques you will use to determine what type of shapes things are. I recommend starting a chart of what tests you need to do in order to determine what a figure is. All right, if you have any questions at all, please feel free to reach out for some help, and I'm happy to help you. Have a great day.